All right. Yeah. So welcome back to this YouTube channel. So in the last video, we have built a convolutional layer, right? So we have developed a little bit more sophisticated neural network layer in which we had two-dimensional and three-dimensional. We had two-dimensional weights, right? We had something called kernels, and you looked at you must have watched that video. So you have the idea like how does the matrix multiplication happen and how does these weights get optimized, and I hope you watched that video. So in this video we are going to go into like a bunch of topics. So first we are going to these are the topics that we are going to learn. We are going to see uh, why should you use a convolutional neural network rather than using a simple neural network. And then we are going to see some new layers, some new techniques, and then we'll develop this CNN in TensorFlow in order to solve any problem. All right. So first, why should you use a CNN? What is the what is the necessary of using a convolutional neural network when you can use a normal neural network? Right. So you can just have these pixel values and assign weight for each value and just flatten the image will be two-dimensional, right? You can just flatten the numbers and use it as a neural network. Why shouldn't you use that? So there are a couple of reasons, right? So I'll just so there are a couple of reasons why you should use CNNs rather than neural network. The first reason is, right? So let's say, okay, so you have like in the images. So especially in this age, where the images have a lot of pixel values, right? So there are many pixels in each image, and there are three channels, RGB channels, and then in each channel there are like many pixels. So if you want to use a neural network, you have to assign a new weight for each pixel value, and then you have to carry out that for many layers. So that will cost a lot of computational power. That means you need to access, like, you have to perform a lot of multiplications, like when you are assigning new weight value for each pixel value, and then you have to update these weight values, and you have to make, and in order to have higher accuracy, you have to create a lot of layers, which will cost you a lot of computational power. You have to carry out a lot of multiplications, and let the input progress in your neural network, and you can finally get the output. That's the first reason. And the reason number two is why is the first reason not applicable to CNN means, in a CNN, right? So you have one kernel and you shift this kernel throughout this image, and then you have only and that in this kernel is static, right? So you have each kernel will have its value and will loop through all of the image, so you don't have to create new weights. All right, you don't have to assign a new weights for each part or even each pixel. So you have these weights, and you can apply as many kernels as you want, and then it is definitely computationally it is less complex than the neural network. And then the second reason is, you have like, if you look at an image, right? So in an image, especially when there are a lot of pixel values, it is more likely that the neighboring pixel values have um, equal patterns, right? So there will be patterns in like patches of images. So let's say you have a whole image, there will be relations in each patch of this image, right? So here one color will be here, like there will be some patterns, and these patterns can be tracked and extracted by these CNNs, right? So these important patterns in image that are between some patches of data will be tracked by this CNNs, and that's a very I think that's a very good advantage we have by using CNN rather than a neural network. So these are the reasons why you should use a convolutional neural network rather than a simple neural network, which is computationally ineffective, and also it doesn't extract fine features. Right, so that is the first thing you should learn. You should just first, before you're building something, you have to learn why are we building that. And then let's see the next layer. Like we let I'll introduce two more layers for us in CNNs, right? So these two layers are like, they have a very much big role, or they have big huge part in building CNNs. So first layer is max pooling layer. So we have two layers, max pooling layer and dropout layer. I'll just explain what each means. Right? Okay. Yeah, let's go to the whiteboard. So let's see what is the max pooling layer. So let's say you have an image, right? So here you have an image and you have performed a convolutional operation. Let's say you have one CNN layer, and let's say this is the output of the CNN layer, just for this purposes. Let's have this. Let's say this is the output of CNN, and then if this image is like a lot bigger, let's say this image is a the output of the CNN is very large image. Like what you want to do is you want to, number one, reduce this dimensionality of this image, number one, and number two, you want to increase. Let's say there are a set of factors that are very important in images. So let's say we have let's say we want to build a face classifier image, face classifier. All right. Let's say you want to build a model that can um, classify images between me and let's say anyone. So there are some important features. For example, I have let's say my face is a little brown, and let's say the other person is a little white. So there will be some more like features like this are very important, right? So these features are should be prioritized more, right, rather than the, let's say, the background color. So let's say the background color of my image and the other person image is same, then we should avoid this feature because it is not important. All right, these features, the important features and the not important features, are figured out by the computer, right? So and then if you have an image, right, so CNN will figure out the important features, and what we'll do is, right, so we'll have a, like, let's say this is the image. Let's create one more, right? So this is the image. All right, so this is the image. Let's say, and what we'll do is we'll just look at each two pixels, let's say, and then we'll get the maximum value, which pixel has the maximum value, and we will spit out this pixel. First we'll have this two boxes, and then we'll shift this, get the next pixel, right, and then we'll shift this and we'll get a smaller image, right? So we'll get image like this, or even smaller, or like, don't care about the dimensionality right now. So what we'll do is, the idea is, removing the minimum values and getting the, like, keeping the maximum value. So let's say in this patch, like throughout this patch, the maximum value will be kept at the output. So hence we'll have a smaller dimension and more like stronger features for the next CNN layer to operate on. So if you have stronger layers, then of course CNN will perform very well. So that is the max pooling layer, why you will need a max pooling layer. And then there is one more layer that I want to talk about, which is called the dropout layer. And when I talk about the uh, role of this layer, you might be surprised like how we can help, but I'll just tell you it. So what is a dropout layer means? Let's say you have a neural network or CNN, and then with some neurons, let's say you have some neurons in the CNN, or let's say this is the neural network, and then if you have more neurons, so you have more connections, right? And then what this dropout layer does is it'll just remove some of these neurons, just like that. So it'll just turn some of neurons outputs to zero. Like that is the function of dropout layer. You can just drop 20, you can drop 20% of your neurons, 10% of your neurons, or whatever. So what is the use of this layer? Why will we use it? Well, in some situations, let's say you have the training data, right? So uh, let's say again we'll take the example of a face classifier, right, image classifier between my image and another person image. Let's say all of the training images, all of the images that we train on model on has a red background. So let's say or let's say my images has yellow background and my friend's images has red background, and some of my images are of different backgrounds. So what happens is, if we had no dropout layer, and if our model is so much complex, right, so even so the model will care about little features. So uh let's say there is a small black dot in the background image, then it is going to care about that black image also, because the model is too complex, and each neuron will get a feature, right? So the possibility is that even little features that doesn't matter will also be taken place by the model, and that is very bad for the model, right? So you don't want to have unnecessary unuseful features to be detected by the models. Hence, therefore, what we will do is we'll just remove the unnecessary features. So that is why we decrease the complexity of the model. We'll just cut off this neuron just by that, just randomly. We don't have any criteria. We'll just drop 20% or 30% of the neurons, hence uh, leading to better accuracy in terms of generalizing the performance of the model. That is a dropout layer, right? I have discussed the reason of max pooling and dropout. Now let's get to the stuff. Let's build a CNN in TensorFlow. So I want to introduce you to a website. Let's say, especially as a machine learning engineer, you should uh, know about this website. This is called Kaggle website. This website is called Kaggle, right? It's a very good website for anyone interested in AI or something, right? You can just get here, and then like you just get this good interface, and you can log in. You should log in or create a new account, and then here go in this section, go to data sets. It's a data sets, and then here in the search bar, you'll get a search bar. You can type in any type of data set you want. Just search for image classification. So we are doing image classification right now. So you can just search for image classification, and then you'll get a bunch of data sets, right? So you have Intel image classification, 100 sports images, right? So you have cats versus dogs, and then you can just go on, right? You can just search for many data sets, and I found one interesting data set for me. This is the data set, villains image classification, right? So what is this data set? I'll just explain it to you. So we have right so we have here we have some images of different characters such as like Joker, Thanos, and all that. So what we should do is we should build a model. So we should build a CNN model that can detect the features, and given an image, you should predict what character that is. So we have some images, just 20 images, right? I think I think that would be enough. Right, so we have 20 images. So less image of we have less images, but let's try. Let's see what we how much better we can perform. And in the future videos, we'll try to increase this performance of the model by introducing you to a like some new research, right? So I'll introduce you to some new CNN architectures that are published, right? So there are some architectures such as Resnet and Inception. So these architectures are, they follow like a new idea in which I will explain. I'll explain them in the future. So you'll get this interface when you click on new notebook. So just go and click on new notebook, right? Then this is exactly like Google Colab, right? You can just write your code and run your code. It is also a very good place for developers. And then you'll get this code cell. Don't run it. There is no need. Just create a new cell, delete it, create a new cell. And first, let's start off by importing the necessary libraries: NumPy, TensorFlow, and then what do we have? Matplotlib. I'll import a new image as mpimg, and then import matplotlib.plt as plt. Right. So these are some libraries that we'll be using. Just run it, and it will start a session for you. So first, it will download the dataset for you. Like if you look at the data set, it is a very small number of images. We have just 20 images, right? Let's see how we'll perform, how much better, like how better our results will be. So that, so we have some images. You can just go through the images, right? Matplotlib.plt. sorry, pyplot. Sorry, spelling error. I'll run that again. Right. So wonderful. We have this. We have this code running where this session is also started. Now you can just change the name of this notebook, like anything, like put something like CNN in TensorFlow, anything like that. So we have this new notebook. Let's start building. So first, we have these images, right? So the first question that will be that will get in the mind is, we have this JPEG images. So how can we convert these images into NumPy arrays, right? So we have this. That is why I have imported this library called matplotlib.image, right? So we'll use this library. So first, what we'll do is we'll just loop through all of these categories, right? So we'll create a list in which we'll store the, so we'll create a separate list for which store the all the numpy arrays of all the pixel values of each image, and then in the next list we'll create categorical variables, right? So zero for let's say this one, and another number for this one, and all that, right? So what we'll do is, first we'll also import another library called os, which helps us to loop through all of these images and access these directories. So what I'll do is, I'll just go through and copy this. Let's, I'll just, here os dot listdir means it will just give us all of these images inside this directory. So we have this directory, right? Inside this directory we can loop through. So this command here will just get us access, to loop through all of the names of the current directory or this directory, and then we can just loop through this directory using the for loop, right? And then you can just, if you just print it, you'll get all of these values. You'll get the directories here. So in the, here in this main directory I have further this 1 2 3 4 5 more directories. So what I'll do is, right, just see, I will further loop through I'll just say for j in I, right? So I have or I can just say os.listdir. Let's just copy this and I'll add I, or I can just say plus I. So what you can just understand what is going on here. So here I will give me a variable name, that is, for example, green goblin. So what I'll do is, I have to get this main base directory. So I'll get this main directory, base directory, and I will add this value, so this string value to this main directory, such that I could further loop through this directory. All right. And then I'll just loop through this directory. What should we do? We should first convert these images into now images, right, a numpy array. So I'll just create a uh, list called images. So what I'll do is, I'll just say image equal to mpimg.imread, and then what should we do is, we'll just copy that again. I think I've already copied that. Paste it. Add j, or I should say plus I plus j, right? So I should also add I, right? So I will just put this here, and I'll say plus I plus one plus j. So understand what's going on here, right? So I'll first loop through the directories, right? So all of these directories, all of these names, and then I'll further loop through these directories, in which, like, these directories contain images. So I'll just further loop through the images, and then for each image I'll just convert this image into numpy arrays, literal number values, right? I'll just convert these images into number values, and then after I convert these images into number values, I'll append this. I'll add these image values to this main list. Understood? And then what should I do again? I should create a labels. I'll just create another variable called labels. Say that. And then what should I do is, let's say labels dot append. What should we do? We can do one thing. We can just say, um what should we do? I think we'll just add I or add j in order to convert them into, we will figure it out what we'll do. So we'll add j to this. J means what is the j here? Actually I, right? So yeah, what is I here? I is the name of this character, what the character is. And then j is the name of the image. So image of this character, we have multiple image of the character, right? So I is the name of the character and j is the name of the image. So we'll just say, I'll just append the name I to this labels. And if I just run it, I think I'll how it runs, right? And if I look at images, I can just print images. I get this huge list of all the image values, right? So it is very large, in fact, right? And let's print the label section. Hope it, yeah, we'll get these values, right? So we'll get 20 Darth Vader values, 20, yeah, hopefully. And then we'll get all these values. So what should we do? Well, number one, these are the things that we should do. We should loop through these image values and then convert them into zeros or ones. So we'll just, what we'll do is, I can just say for I in labels, let's say if I equals Darth Vader. So if I has the value of Darth Vader, what I'll do is I will just say, or I can just create a new list. I know this is not computer, like, okay, we'll just create L. I'm going to say L dot append 0. Then LF I equals, I don't know what is it, uh Thanos L dot append, it's a 1. LF I equals what, next what we have, Green Goblin. I'll add 2. All that, I'll add 3. Then finally we have, right, I'll just do this. And if I run it, yeah. And then if I just um look at the list I L, sorry, we have this list, right, where we have these combinations of zeros and ones and twos and threes and fours. So right, we have our training data ready. So we have all this training data. We have the images as well as the labels. So let's start building our model. Let's see how our model will look like. So first we'll use the TensorFlow model sequential library. As I say, keras the models sequential. And then we'll create a new list. I'll add CNN layers. I'll just say conv 2D. So to add a CNN layer, you have to use this function of uh, tf.keras.layers. So you can just say tf.keras.layers.conv 2D. It will help you to add CNN layers which are of two dimensional CNN images, CNN layers. And then you can just say how many, and the inputs are the number of filters. So what are how many filters you want, or how many kernels you want. Let me just say 32 here. And what are the sizes of these kernels? So what should be the size of this kernels? And then I think that's it. I think that's it. That is enough. And we'll also add another activation function. There is no need, but I'll just add a ReLU activation function. And then let's add a max pooling layer. Max pool 2D, right? And then let's do another CNN layer, just one more. And then let's do 64, or let's do something like or we'll do something. We'll start off by 64, and then we'll reduce it by 32, 3 by 3. Activation equals redo. And then we'll do the final max pool. And then and what should we do? We should flatten out this outputs, right? So we should just convert this two-dimensional outputs into single dimensional vectors. And then let's add a dense layer to perform the fully connected operation. We should create a neural network, right? Let's say we'll add I don't know, 256 neurons. Activation equals relu. And then let's add a dropout layer now. So in order to, you know, reduce the complexity of the model, we'll add dropout, 20% dropout. And then let's finally add the final dropout layer, so dense layer, right? And then how many outputs should we do? Well, as we have a categorical output, we should have five five neurons. Five, and I'll just activation equal softmax. Let's understand what's going on. Simple model. Sorry, spelling mistake. Just put that capital. Oh, another spelling mistake. That's true. Good, good. Now let's compile our model. Compile our model. Optimizer equals Adam optimizer, and then loss equals to, we have a new loss function. In order to do uh, multi-class classification, we have multiple classes, right? So we have multiple outputs that can happen. So we should classify these images into five different classes or five different groups. So in order to do multi-class classification, we should make the loss to be sparse. I think cross entropy. I think, or I'll just look it up. Let's just see. Activation function for multi-class. I think the name is. I'll just look that. I think it is Mars categorical cross entropy. Not sorry, not activation function. Loss function, right? I think there are two loss functions. Let's just look it up. I forgot. Okay, we have binary cross entropy. Okay, that is for binary classification. Yeah, sparse cross entropy, or is it categorical? I think it is sparse categorical, or let's just say sparse cross entropy. Let's try it, and then we'll probably change it. And then let's look at accuracy, right? And then let's compile our model. Let's see if this is the accurate function, loss function. Okay, tran, wonderful. It is sparse cross entropy indeed, and we'll fit the model, right? So we'll just say model dot fit. I'll say history is equal to model dot fit on. What is the training data? Well, we have image, right? Images, number one. And then what is the labels? We have L. And then we'll just set the epochs to number of epochs to, let's say, 50. Let's try 50, and then that's it. So we'll just run it. So wait a minute, I have to convert this images list into numpy arrays, because in TensorFlow, the fit function only accepts numpy arrays. So I'll just say images equals np dot array of images. I'll just do that. Hopefully that work. Now let's run this. Okay, class numpy array. All right, so it might take some time, right? So okay, so yeah, yeah. In the like before, like I just paused the video. So the reason of me pausing the video is I think there is a problem with TensorFlow. It is not able to convert numpy arrays into tensors, right? So that is why I think image processing is a little bit harder. So like there is a library called image data generator. I thought of sharing about this function in the next video, but I'll just go through that now as we have needed it. So image data generator, it just convert this images into a more comfortable format for TensorFlow to run the model on, and we'll also have some more options such as setting the target size of the image into. We'll just convert this image into 150 by 150 pixels, and then we'll also have this class mode, and you can just input the folder, and it will do all the image processing for you. So I just run it, and then I just run this, and now let's run the model, see if it works. Yes, it is working. Yeah, starts off very with like 40% accuracy is enough. Like we have one, two, three, four classes, right? So we have four classes, sorry, five classes. So 80% is, it is also going to 87%. Wow. 93. I think we don't need to run for 50 epochs. I'll just stop it. I'll just stop it here. I'll stop it after 10 epochs. Let's see what accuracy will hit. Wow, one. We have 100% accuracy. Okay, we have 100% accuracy in just the 10th epoch. Yeah, I'll just stop it. Just click on this button. So yeah, we have 100% accuracy, that is which is really amazing. But still, as we have lesser images, just 20 images, like even for testing, as we have only 10 20 images for testing, it is possible. But just learn about this model, how to build this model. And yeah, and remember, keep learning. I will stay. I'll I'll try to make a video every evening. Just practice as much as possible. Read the documentation. There are like a number of articles, and there are number of research going on. Go to paperswithcode.com. There will be CNNs and different architectures. Try to read them all. Just I mean, like, just go through my past videos, and hopefully, and you'll get better at this thing. And then in the next video, what in the next video, I think we'll go through natural language processing. We'll go through text classification. How can computer deal with text? I think let's see. So see you in the next video.